All right, so we are now on 3.3/3.4, and today again is one where there's sort of a notes page. If you would like to print, you can. If not, just kind of copy down the parts again that you would want. So the warm-up, which is on that little side paper, I didn't want them to do all of them, but just to kind of practice, if I told you that these two angles are congruent. Now, I don't care what they look like over here. This is just like not to scale. The lines could really be doing anything. So if these angles are known to be congruent, does that mean that either the TS pair are parallel, the LM pair are parallel, possibly both, or none, because it's not enough information to guarantee that it came from a parallel situation? Or I just think that it would mean that they definitely weren't parallel. I would still put none. So I just want you to practice that. Mostly we're kind of thinking about our vocabulary words, which ones are supposed to be congruent, which ones are supposed to add up to 180, and then sort of see what's going on with that. I also have on that same warm-up page an algebra type problem where I give you information about, now I'm still referring to this diagram, so angle 12 and angle 3 are from this picture. If we know that those are parallel, and I know that these are the measures, could I find them? I don't just find the other angle measures. It's because if these really are parallel, then like all of the acute ones are the same answer and all of the obtuse are the same answer. So really just get me the value for those angles. So again, if you want to try that out, go ahead and put pause on this video. Otherwise, I will reveal the answers in 5, 4, 3, 2, 1. Okay, so 1 and 14, just to kind of highlight where those are. These, well, not just would be, these are alternate exterior angles. And if we are in a parallel situation, then those are going to be congruent. So if they are congruent, I would know that the lines that are parallel are these two that are being connected by that transversal. So mostly this is not just saying that you wouldn't know something is parallel, but to make sure you're labeling correctly which set of parallel lines. Okay, as far as 2 and 3, these are CIAs, and so let's say this had been like a parallel situation, right? CIAs are supposed to be supplementary and add up to 180. So if we're telling you that they are the same as each other, it likely means like if 2 is more of an acute angle, that this is more like a matching acute angle, and therefore they're definitely not parallel to each other, right? So if you got a little stuck, that's generally what we're talking about. I'll look at the other two that say none just to see if I can point out why. 13 and 10, these are a vertical angle. They're gonna be congruent no matter what is happening in the picture, so there's not enough information to guarantee because they're gonna be congruent. There's no way for those not to be congruent. And then 16 and 4, these are, okay, if we were parallel, these are not a specific vocabulary. It'd be like same side exterior. So they're kind of like they match up with CIAs. Like these would be, because again, I know it's not to scale, but if these were parallel, this would be an acute with an obtuse and add up to 180. So the fact that they're congruent to each other goes against what the vocab word is supposed to do. So we're not going to be parallel. Or like I said, if this intersection here is truly acute, then this line probably also has to make it acute, and then these are definitely not parallel. So again, just things to look at, things to practice the vocabulary, and just kind of practice looking at diagrams. The next part, I basically just kind of wrote a big old explanation of like why I got the answer that I got. So I did say we're going to assume that they're parallel, and angle 12 and angle 3 add up to 180. That's because 12 and 3, it's a 1 acute and 1 obtuse. Even though these aren't specific vocabulary, I know in a parallel situation, one of each type is going to add up to 180. So I needed to put that logic together that those two things added to 180. I then had to get this condensed for factoring, so combining these up, moving that over, getting to this step. If I can get here successfully, then I get the factors, and from the factors I pull out the two potential solutions. Because it's still negative when plugged in is why that doesn't work. So when I went back, of course, I didn't want to plug it into the squared one, but I plugged it in here. I'm going to be honest with you. 18 times 30, I was like, well, 18 times 10 is 180. So negative 180 is already going to be super negative compared to only adding 120, and it's 3 times as much. So I knew that was like crazy negative and no. and when I plugged in 2, it did work, and I got 2 answers for those. But it does remind you that if both work, then you must include both sets of answers for full credit. But again, this is a situation where only one did, but kind of keep practicing that. All right, so today is kind of a review of Algebra 1 Day, just our slopes. Like this is a positive shaped slope, negative shaped slope. And then for 0, it's a flat horizontal line, and undefined, it's an up-down vertical line. So if you don't know those for whatever reason, like here they are again, you should have seen these before when we've done our transformations unit, that very first chapter 9 unit. Like this would be like an x equals style graph versus a y equals style graph. And we recognize them as horizontal and vertical. We just want to make sure you know that flat is 0 slope, straight up and down is undefined. I don't want to get into a whole lot of details about it, but basically, if I were to take 2 ordered pairs and I asked, how far up did I go? Well, nothing. And how far over did I go? Let's say I went over 2. If you type 0 divided by 2 in any calculator, it's going to say 0. That's why that's called slope 0. But here, let's say I took these 2 points and said, well, how far up did it go? And let's say that was up 2. How far over did it go? And over 0. If you stop right now, on your phone and type 2 divided 0, enter, it literally says error. A lot of students think it's going to be 0. It's like, no, this is, I have no candy bars and there's 2 of you sitting here. Great, you each get no candy bars. Like I can give you 0 each. But what I can't do is be like, hi, this is a KVA video. There's nobody in front of me, but I have 2 candies, so I'm gonna split it up into nobody. You just physically can't do that, and that's why there's an error there. But just, that's a little bit about why that's called undefined, in case you are curious. All right, graphing. The 2 of these 4 that I would love for you to know right away without even questioning yourself is that this one starts at +3, the slope is down 2 over 1, boom, boom, make a line, call it a day. The other one that we've already done enough in this class and I would love for you to be comfortable with is knowing that a y equals with no x in it is a horizontal graph, in this case at -2. Okay, if it was an x equals, it would be a vertical line. Now these other 2, there are some interesting trick ways to graph these. You are also, of course, welcome to like physically try to solve them. One thing I'm going to caution you on is that they don't always work out to nice numbers. So for example, if I did want to solve this, subtracting 2x to the other side, I get -3y is -2x plus 12. And then I divide everybody by -3. And I get y equals, now 2 doesn't divide by 3, but negative over negative cancels. So positive 2/3 x minus 4. And now I can graph it just like I did over here. Starting at -4, yes. And then up 2 over 3, up 2 over 3. It's just some kind of like algebra review. Point slope form, and we're going to talk about this more in just a minute because it is super important. But point slope form, there's like a point hiding inside it. And I remember because it looks like a parenthesis, reminds me of like a parenthesis point. And the main trick to know is that these are both opposite sign from what the actual point is. And I have the formula I think on the next page we'll look at. So the x value is really +2. The y value is really +5. And so this isn't like a traditional starting point on the y-axis like these do, but it is a starting point that is somewhere on this graph. So 2, 5 is 1, 2, 1, 2, 3, 4, 5. And from that point, I can still count the slope, like up 2 over 3, up 2 over 3, and still draw my line. Now, why it's helpful to know that is, let's say you didn't know that, and you were like, nope, I have to solve this by hand. Well, 2/3 x is no big deal. But 2/3 of -2, well, top times top is -4, bottom times bottom is 3. You end it with like a nasty yuck fraction. And I need to do a +5 to the other side. Common denominator, add them together. It's going to be a nasty fraction that's not even nice. In fact, if you count this slope backwards, like 3, 2, 3, 2, 3, 2, 3, 2, you'll notice it's not crossing somewhere nice. And we've done the math to find that yucky number, but that fast way of graphing will always work whether this would be nice or not. You don't even care, you don't have to check, but you've got to remember that the point looks opposite. So if I just randomly gave you like y minus 2 equals 4, x plus 5, you would say, there's a hidden point in here, it's at -5, positive 2, and I would just go to negative 5, 2, and then start counting the slope, 4, 1, 4, 1, and get my line. Okay, knowing that is going to be super helpful, generally speaking. Okay, what we're also refreshing today are parallel and perpendicular slopes. So parallel means that they have exactly the same slope. Perpendicular, the technical math term is called an opposite reciprocal. And what that means is basically flip the sign and flip the fraction. So, for example, if I told you that the slope was 2/3, what is the parallel slope would also need to be 2/3, right? They both go up and over the same constantly, they're not going to cross. And what's considered the perpendicular slope is when you flip the fraction over 3/2, and if this is a positive fraction, it is now a negative fraction. So I don't want you to think about flipping the signs of both numbers, it's flipping the sign of the total fraction. So negative 3/2 would make 90 degrees to a 2/3. In fact, I've got a bit of a grid here, so I'm just going to show you that if I have a slope of up 2/3, and I have a slope of down 3/2, and I draw all this super carefully, that will always be a 90 degrees when you do that step. Any other combination, they'll cross, but they're not going to cross at a 90 degree unless it's opposite sign, opposite fraction. Again, opposite reciprocal is the formal name for that. So, I mean, you can know all the names of these forms, but the two that are probably the most important, it's what's called slope-intercept form, is your normal mx plus b, because you know the slope and you know the intercept on the y-axis to start at. This other one is called point slope form because it has that hidden point inside of it and then the slope that you can count from. And again, you'll notice the negatives in the formula is partially just a reminder that those are opposite signed from what they observably look like. And usually with standard form, there's some tricks to this, but most students are just going to subtract the x over, divide, and just make it look like the first one is the way that I personally usually do them. So here I wanted to show you how point slope form can be easy when you just take this and plug it in. You have y, you do the opposite sign of the y point equals slope x opposite sign of the x point, and literally you'll leave it like that. You're done. Don't do anything else. Now, if the question said, nah, but I want it in slope-intercept form, you have two choices. You can either start like this and then start solving, like 1/3 x, that's negative, 1/3 of 6 happens to be a perfect number of 2, subtract 3 to the other side, and I can solve this for 1/3 x minus 5. The other way to do it that might look familiar depending how you learn to do this is you sort of borrow in order of mx plus b. So you never even start like this. Like you just like, nope, don't do that. And you go, well, I'm borrowing the y as -3. I'm borrowing the slope, which is 1/3. I'm borrowing the x with the 6, and I need to solve for my plus b. And I want you to notice that I'm not changing the signs of them here. That is just a special feature of point slope and not to get that confused. You'll also notice I tend to write capital B a lot because in my work, a lowercase b can start to look like a 6 if I'm being sloppy, and I don't like to get that mixed up. So then I'm doing 1/3 of 6 is 2, subtract 2 to the other side is -5, and I find out that the b value is -5, and then I'd like to fill in all of my information, the slope from earlier and the b I just found. So you kind of have options, and if that seems a little overwhelming, you might want to rewind and look at that, but we are going to go through several other examples right now. These are all on your paper, by the way, moving forward. If that one wasn't, I'm not sure, but I know these ones are. So write the equation. Well, A, I need to find the slope. I find the slope by just stacking these like a little table and counting how far it happened. There is a slope formula. That's too much. Like y2 minus y1, x2 double negative, flip this. No. Just stack these like a chart and go, how much did I add or subtract to go from the first point to the second point? From a -5 to a -2, I actually added 3. And from a 6 down to a 2, I subtracted 4. So just checking, I didn't say that wrong. 6 minus 4 is 2. Yes. -5 plus 2 is -2. Yes, slope is y over x, so negative 4 over 3. This does not divide or reduce. That is the slope. If I want point slope form, that's this one where I get to just throw the information in. You honestly have 2 points to pick from, so there are 2 completely correct ways to write this answer. If I go with the first one, it's y opposite equals the slope you found, x opposite. The other choice is y opposite equals the slope we found, x opposite. And both of these separately are perfectly correct answers. You would not need to write both, they're just both correct. And I don't want to work through the math because I can tell the answer would be a fraction, but if you were to distribute this in and move this over, combine it all up, you would end up with the same like y-intercept solved piece at the end from either one of those. But again, why we like this form when we're allowed to use it is because you don't have to solve and deal with the yucky fractions. It just stays where it's at, cool, done, finished. Let's do one we're doing in slope-intercept form. So I'm going to stack my points, find what happened. From 4 to 7, it's what, plus 3. From 2 to 6, it's plus 4. So 4/3 is my slope. So you have 2 completely fine choices for how you like to do your math. You can be so excited about point slope form that you could always start there and do y opposite equals slope x opposites. Make sure you pick a point and stick with it. You can't like blend the points. And if they want in that form, you're good. Obviously here they go, nope, I want it in mx plus b. So now you have to do your math and get 4/3 x. Let's see, 4 times 4 is 16. Over 3 times 1 is 3. Doesn't simplify. Ugh. Then I have to add 2 to the other side. I would need a common denominator, so we're going to times by 3 over 3. Final answer is going to be 4/3 x, and whatever the heck this is. So I'm going to figure that out right now. 2 times 3 is 6 over 3. I'm adding a 6 over 3 to a negative 16 over 3. So negative 16 plus 6 is negative 10 over 3. Okay, that's option A. Now option B is still going to give you a fraction, still have to deal with that math, but the option is start here, solve it. Option B is what I did up here a minute ago, is where I borrowed all the information into mx plus b. So again, pick your favorite point. Let's say that one. 2 equals slope that we found times x, which was 4, plus b. You'll notice you still end up sort of doing this same math. Like 4 times 4 is 16/3. You now subtract it to the other side. You get 2 minus 16/3. You literally do the same common denominator we did a second ago. 3 over 3 gives you 6/3, and 6 minus 16 is your negative 10/3, and you can kind of fill all that in. Again, kind of want to practice that, maybe pause the video, like work through that and be like, okay, I see it. If they were all whole numbers, maybe it'd be less scary, but we're pre-P and we're going to throw it all back at you. Okay, a couple of different examples. Write an equation, slope-intercept that is perpendicular. So this time they're like, oh, do you know what perpendicular means? Perpendicular means the opposite reciprocal of this slope. So if this is currently a positive fraction, it's now a negative fraction. And the 1 over 5 is going to flip to 5 over 1. In this case, that just means the slope is negative 5. It says write an equation in, okay, it says slope-intercept. So I have to write it in slope-intercept. So let's say I choose to do it this method. Y is 0, slope is negative 5, because I had to know that that's what perpendicular meant, and I'm kind of borrowing that to figure that out. The x value is 2 plus b. So this is negative 10, added to the other side is positive 10, and I put my equation together. Negative 5x plus 10. You'll notice this math is far less scary when there aren't fractions involved, right? Those last examples might feel overwhelming just because there's a lot of fractions involved. Now it says also, same question, but let's pretend instead of perpendicular to that point, it said parallel to this point. Well, parallel means use the same slope. So it means do not change it. You don't even care about this too. I'm just looking at the slope part to know what I need. And I'm going to borrow this point. So the y is negative 3. Here's my slope. Here's my x plus b. Top times top is 10. 5 times 1 on the bottom is 5. I'm actually extremely excited that that divides to the number 2. So I subtract it over, it gets -5 pretty quickly. So y equals the parallel slope that was the same with this -5 that I found. Okay, so again, fractions aren't always scary if they clean up, but if they don't, it gets a little messy. Okay, yeah, these are our last couple of examples. So write an equation in the slope-intercept form for line and perpendicular. Wait, we already did that one. Literally, we just did that one. Or is there something different about it I'm not seeing? Slope-intercept, perpendicular, parallel. You know what, just for the sake of changing this up, I'll probably do this in class. Instead of slope-intercept, let's do this one in point slope just to show you how much faster and how much better, in my opinion, point slope is. Because perpendicular, I still need to do like the opposite reciprocal and get that -5 is the slope in question. But now I'm going to do y. Opposite is like +0 or -0, but since it's missing, we can kind of just leave it alone. Equals slope x opposite. And really, this would not be that hard to just distribute through because of that 0, but generally that's how that works. Here's his parallel, which means use the same slope. Using this point, we would do y opposite equals slope 1/5 x opposite. And if I'm told to leave it in point slope form, great, because I can already tell this is not going to divide pretty and have to deal with a bunch of fraction math. So as weird looking as point slope is, it's actually your friend. Last example was to discuss parallel and perpendicular with one of our special lines. In this case, y equals 3 is something that is horizontal. So if I'm asking you to write something that is perpendicular to horizontal is vertical. So it's going to be a vertical x equals graph. And what's interesting is that because it's an x equals equation, the y value doesn't even matter, right? Because it's like, hey, there's this point of 4, -5. Can you show me an up-down line that touches this point? The only point I care about is where is that x value. I don't really care where this point was along here. I'm going to list the same thing. So I just care about the x value. And then this is a follow-up. If instead I said parallel, the only thing parallel to a horizontal line is another horizontal or y equals line, and I would steal the y value in that problem to plug it. Okay, so the homework today is actually in that little packet. If you didn't print the packet, then maybe go get that individual page. But it's going to be pages that are numbered at the bottom, 7 and 8. I'm not gonna lie, the very first 4, it says like to count the slope. It's kind of blurry. If you have trouble reading that line, it's okay, just try your best. But the rest of them I think you can see pretty well. The answer key is from last year, and like a couple of the questions at the very end were like switched out. So you have the answers to most of them, and then just kind of finish as you will. Okay, reminder that there will be a quiz coming up on Thursday, that you should definitely be looking at your chapter worksheet because there's a whole lot of it that you're already prepared to look at, and that'll come up faster than you think if you just don't look at it at all. All right, otherwise, you guys have a good day. See you later.